Hello everyone and welcome back. As you can see by this sheet in front of us, we are finally done with triangles. We are moving on for the next 4 weeks. We will be talking about circles and different circle theorems. So this is quite an exciting day. Today we are going to start by talking about the central angle theorem. And I also posted online a vocabulary sheet of every vocab word I'm going to be using in this section about circles, as well as some handy-dandy formulas that could be really helpful in this time. So starting first, we should talk about what is a central angle. So a central angle is an angle that's made up of two radii or radiuses. And what is a radius? Great question. A radius is a line segment that goes from the center of the circle to the edge of the circle. So for example, this is a radius and this is a radius. And hopefully you also remember about circles that all radiuses, no matter where they are around the circle, they're always going to be the same distance. So if this was 2 inches, R to B would also be 2 inches because the distance from the center of the circle to the edge of the circle is the same no matter where you are around the circle. So a central angle is made up of two radiuses, and it could be inside here, or we could even look at this using what's called the major arc, which is the arc that's bigger than 180 degrees, or the minor arc, which is smaller than 180 degrees. So in this case, we're mostly going to be looking at this minor arc, AB. So now, our central angle theorem, what this is helping us with is the measure of a central angle in a circle is the same as the measure of the corresponding arc. So the key word here is same. So when we look at this, if I tell you that this is 120 degrees, this angle AB, so the measure of angle ARB equals 120 degrees, then the measure of arc AB, and I'm going to write it as AB as our 2 points with an arc over top, AB is also equal to 120 degrees. So if we know the measure of a central angle, we know that the measure of the arc that corresponds with it. And you can see, if this is our angle, it kind of makes like a piece of pizza, the corresponding arc. So it's like where you slice the pizza, and then the crust is where our arc is. So that's what we're looking for when we're looking for the degree measure of an arc. So if we look at an example here, example 1, if the measure of angle ACB, so I'm going to highlight that here, ACB is 160 degrees, what is the measure of arc AB? So I'm looking for this. And as you can see, this is their corresponding arc to the angle we were given. So since our central angle theorem says the measure of a central angle in a circle is the same as the measure of the corresponding arc, since we know our central angle here is 160 degrees, we know the measure around our corresponding arc will also be 160 degrees. So now let's just do a couple more examples here. Seems simple, but there could be some tricky parts. Example 2, if the measure of arc DE, so this guy out here, is 120 degrees, what is the measure of EOD? So I just did that right here. You can see we're talking about a central angle, and we know the corresponding arc. So if we know the corresponding arc is 120, we know our central angle theorem says it has to be the exact same thing. So EOD is also 120 degrees. So now let's look what happens in example 3 if we aren't just given exactly what we're looking for. So JL, this line right here, is a diameter. Diameter goes across the whole circle, and it splits it into a semicircle. Makes 2 semicircles. And if you think about it, if we know that this is half of the circle, this guy right here, JML, is going to be 180 degrees. Because if you have half of the circle, and we know a full circle is 360 degrees, the diameter would split this into 180. Anyway, I think we'll get to that later. We know JCK, I'm going to use a different color here. Let's go with this, we'll have green. JCK is 85 degrees. We need to find JK and each of these. So if we're looking for JK, we can see that is the corresponding arc to that central angle JCK that we were given. So central angle theorem says the central angle is the exact same as the corresponding arc, so this guy is also going to be 85 degrees. KCL, we're looking for this guy in here. KCL. This is along the diameter. So if you see we have a diameter, which is a straight line, we should hopefully remember our supplementary angles, or how these are a linear pair. They're along one straight line. Linear pair means they add up to 180 degrees. So if we know the whole thing has to be 180 degrees, we know our green angle is 85. We subtract 180 minus 85. We are left with 95. So that gives us, this is 95 degrees in here. And then KL, that's our corresponding arc. Since we know central angle theorem says whatever the central angle is, the measure of that is, the corresponding arc is the same measure. So this is also going to be 95 degrees. It's kind of nice. And then LMJ is the last part we're looking for, so L to M to J. We already said is 180 degrees because the diameter splits the whole circle into 2 equal pieces. But we could also check it by, we said a whole circle has to be 360 degrees. So if we do 180 plus the 85 we found plus the 95 we found, 5 plus 5 is 0, carry the 1, 8 plus 8 is 16, plus 1 is 17, plus 9 is 26, carry the 2, 360. So we can always make sure everything has to add up to 360. I could have done 360 minus 95 minus 85, and that would have left us with that 180. Either way, our central angles are always the exact same thing as the measure of our corresponding arc, and that is the main point of this video, the central angle theorem. Look at that one more time if you need to write this down. Central angle theorem, the measure of a central angle in a circle is the same as the measure of a corresponding arc. All right, tune in next time for another angle theorem.